All right, quick overview. What I want to talk about is kind of the nuts and bolts of putting a rainwater system together, what type of technologies are available, what types of tanks, pumps, things like that are commonly being used. And when possible, I've used images of projects here in Atlanta to kind of show that systems are going in Atlanta, what type of technologies are being utilized to put them in. I probably haven't covered every single technology out there, but I tried to focus on the ones that we see most commonly used in the industry. So we'll talk about conveyance piping, the pre-filtration, the types of tanks, pumping systems, water treatment systems, auxiliary water supply, and then some of the maintenance involved. I've tried to leave my slides, not bombard you with a bunch of words, so if you have any questions, speak up. I'm just using the PowerPoint kind of as an overview. So system components. Every rainwater system basically has the same system components, whether it's a small system or a large system. So they're scaled differently. Obviously, you have your collection surface. In most cases, we're talking about rooftops, but it could also be, landscaped areas, could be parking lots, other impervious surfaces. Just straight from the rooftop, that's the cleanest and easiest water to use, like Jim discussed. The conveyance piping, that's all the piping that's going to take the water and get it to your tank or your storage vessel. The pre-filtration, pump system, how you get the water out of the tank. The water treatment, a lot by code, if you use the water indoors for flushing toilets or potable use here in Atlanta, you have to disinfect the water. We'll talk about how you do that. And then almost all these systems have a backup water supply, and we'll talk about how you implement those. But first, we'll talk about conveyance piping. Aluminum downspouts, or that's just your typical residential downspouts. You really only see that as your only form of conveyance piping on smaller above ground systems, rain barrels, maybe rain tanks, where they're just taking the downspout, like in the bottom left, right over to the tank and dumping it in the top. So that's kind of the most easy and crude fashion of conveyance. The most common type of conveyance piping we see is some sort of plastic pipe, whether it's Schedule 40 PVC, like you see in the kind of the top left-hand picture, or in the bottom right, you kind of see the thin wall SDR35 drainage pipe. That's pretty common for just outdoor conveyance piping over to underground tanks. In commercial applications, you'll see a lot of cast iron pipe, rain leaders, like you see in high-rise buildings or any sort of commercial application. That's up on the top right. The main thing you don't want to use is, and you see it spooled up on the bottom right picture, is just the corrugated black pipe. We've seen people try and use that for conveyance piping, but there's no way to get a good solid seal when you connect two pieces of it together. So there's kind of issues with that. But in residential like commercial applications, PVC, some sort of plastic pipes would be your most common. In the heavy commercial applications, you're probably going to see more cast iron pipe. Pre-filtration. These are downspout filters. You're typically only going to see these on the smaller above ground systems. It's just a screen. The water dumps in right to the top of the what they call a leaf head or rain head right there, and it filters out the leaves. Clean water goes out the bottom and goes over to a tank. The other one you see over here is sort of similar in the way it works. That's actually a diverter where water comes in. The clean water goes out the side of the tank, and kind of the refuse water, dirty water, goes out the bottom. They call a lot of these filters self-cleaning, but all rainwater filters require some cleaning at some point. But they're marketed as self-cleaning filters. I would call them almost self-cleaning filters. but so these are just kind of your most basic type of downspout filters. Again, usually you'll see the smaller above-ground systems. The in-ground filters for the larger scale commercial or even residential projects are going to be the most common type you see. There's really only a few types out there. Most of these products are manufactured in Germany, because in Germany they've been doing rainwater harvesting for quite a few years. They have a very high adoption rate. Almost 60% of the homes in Germany have some form of rainwater harvesting system on them. So really there's only 2 or 3 manufacturers of these filters out there, and they're very similar in the way they work. They're all gravity fed. All the commercially available filters filter down to about 350 microns. So, the only thing making it through the filter screen is going to be kind of fine silt, sediment, that sort of thing. This is what they would call a cascade style filter, because the rainwater coming from the roof is coming in here. It's cascading over a stainless steel filter screen. The clean water comes to the bottom and goes back out to the tank this way. And then again, they call this a self-cleaning filter because they'll use a portion of the water to flush debris downstream to your bioswale, a rain garden, subsurface detention, that sort of thing. You can actually equip these with a spray head, a pressurized spray head, so you can blast off that filter stream periodically. So again, they're marketed as self-cleaning filters, but over time what will happen, anytime you have a screen that's as fine, 350 microns is a very fine screen, the more water that flows over it, it'll kind of develop a biofilm on it that you can't even necessarily see. And that's what needs to be broken up, and it just drops the efficiency of the filter. Usually they are self-cleaning in the fact they get rid of the big stuff, the leaves and the roof grit, but you do have to clean off that screen to remove that biofilm so the filter remains efficient and working. There's another style, vortex style, where the water enters the filter and kind of spins in a vortex fashion. It's the same basic principle, same filtration level. But again, these are probably the most common for commercial or even residential systems where you have below ground tanks, or even for some use with above ground tanks. The reason that pre-filtration is so important is because you want to keep all the trash out of your tank. It's a lot easier to access that filter and clean that filter screen off every now and again than it is to get in a tank and muck out a tank and get all that stuff out. So pre-filtration, in terms of project cost, it's a very, very small amount. It contributes a very small cost to the overall cost of the system, but it's very effective and crucial for keeping the tanks clean and keeping the maintenance on the tanks down. Additional pre-filtration. So by the German model, there's actually 4 components that make up the pre-filtration. The pre-filter that we just saw, and then they also use a calming inlet, an overflow siphon, and a floating extractor. And I'll go back a couple slides and show you where these are in the tank. So if your water's come off your roof, it's gone through your conveyance piping, through your pre-filter, and then it's going over into the tank. So as I mentioned, 350 microns is the filtration level, so the only thing getting through there is fine silt, debris, sediment. What happens is when that goes into the tank, it will actually settle out on the bottom of the tank. Really, it's not detrimental to a rainwater system. It doesn't hurt it as long as you treat it right. What you would like to do, if you have your sediment bed sitting on the bottom of the tank, rather than every time it rains, just dumping your water right on top of it, churning it up and suspending all those particles, typically you want to leave it intact on the bottom of the tank. So the water would flow into the tank and go through the calming inlet, which actually broadcasts the water up into the tank so you don't disturb the sediment bed. Then you move on to your overflow siphon, kind of looks like a P-trap there. So you have your sediment bed intact on the bottom, and there's some things that float on top. We call them floatables, so like pollen. If you ever look in some of these tanks in the pollen season, just the whole top of the water level is usually yellow. Actually, as the sediment bed on the bottom starts to break down, some of that stuff will float to the top. So when the tank overflows, the siphon actually kind of creates a siphon action, just like it sounds, and pulls all the floatables off the top. So you left your sediment bed intact on the bottom, you're pulling all the floatables off the top, you've pre-filtered to 350 microns, and then kind of the last step is your floating filter. And that's going to be the intake for your pump. In any water column, whether it's a tank, a pond, a well, whatever it is, the cleanest water is generally 8 to 10 inches down from the surface of the water level. That's where the most oxygenated water is, all the sediment is settled out. So this floating filter, go back up to my original slide here, this guy here, it's literally just a plastic ball, air-filled ball that floats on the water surface with a filter screen attached to it. This would go around and be attached to the suction side of your pump. So as the water level in the tank changes, that floating filter is going up and down with the water level, so you're always taking the cleanest water out of the tank. So if you combine all 4 of these elements, the pre-filter with these elements, you're actually going to end up with pretty high quality water. At that point, it's generally suitable for irrigation. If you're doing drip irrigation, you might want to put in some additional, some finer filters. And then, of course, if you're doing toilet flushing or potable applications, we'll have some water treatment after the fact. But that's the basic pre-treatment method there. We'll get into tanks. You might have seen this picture on Bob's slides. This is a project in Decatur. As I mentioned, I tried to use real projects locally here so we can look at them. This was a group of 7 1,700-gallon below-ground plastic tanks. It's a 12,000-gallon system. It's at the Oliver House in Decatur. It's a senior living facility. The tanks are modular, so each one of these tanks is 1,700 gallons. They're plumbed together at the bottom and the top. You don't see the top plumbing's not done in this picture yet, but so it's 7 tanks acting like one 12,000-gallon tank. Below ground plastic tanks like this are very affordable. They're pretty easy to implement. They're less cost than, say, the fiberglass tanks we'll talk about in a minute. You can't use them where you have heavy vehicle loading applications. They're really only good for about 3 tons of vehicle loading. So if you've got a system, say 12,000 gallons or under, and it's not a vehicle loading application, the below ground plastic tanks can be a really affordable way to implement a tank system. You see them used in commercial and residential applications. We sell quite a few just 1 and 2 tank systems for residences. So that's a very common system. And you also have the plastic above ground tanks. I believe this picture is at the World Congress Center, but I'm not positive. But this is kind of rare that they're using a plastic tank inside a building. These tanks also go outside the buildings. This is a good picture because you can see where they've retrofitted them on that in-ground filters for above ground use. So the filter's up there, the pre-filter's up there on the left, goes into the tank, and they have a pumping system here. Again, for above ground systems, plastic tanks are the most affordable, they're the most common. There's many manufacturers of them. The largest single tank any manufacturer in the States makes is 12,500 gallons, but again, you can link them together to come up with bigger capacities. They're UV resistant. Again, affordable. Shipping can be kind of a bear with them. Shipping can be really expensive, but there's enough manufacturers with enough plants around the United States that generally you can get a tank within a few hundred miles of your project. Another plastic above ground tank would be the pillow tanks. Jim's the expert on these. He's the granddaddy of the pillow tanks. Basically, and I'll look to Jim for some backup on these. You can build a pillow tank in any size. Basically, you can have them custom made to any size you would need. I think there's many perceived advantages of them because they're easy. They're definitely not having the shipping issues you do with some of the larger tanks. If you ever want to move this tank, it would be very easy to move the tank. They're UV resistant. They're expandable as well. And again, if you have a specific area, you can customize the tank size because they can make custom sizes, and put it in for you. Great for if you're putting in crawl spaces, so it works well in residential applications. The actual liner is freeze resistant, and so you're not going to have issues with the tank cracking or anything like that during freeze. So another good above ground plastic tank system. Then we'll go to that was it, Gwinnett Tech? Gwinnett Tech. Okay, so that's another local project. You can see, these, and I believe this was a mobile system. They moved this one around?
They moved that as they build new buildings to go ahead and get those plants established.
Okay, to establish landscape. Okay. So now we'll move into below ground, the fiberglass tanks. These top 2 pictures, this picture and the top picture, that is the carbon neutral laboratory over at Georgia Tech. That was, I believe, a 20,000 gallon tank. Probably says right on the end there. But so when you start getting into the heavier commercial applications, generally you're going to see a few different types of tanks, fiberglass being probably one of the most common. The largest single tank they make is 60,000 gallons, but again, you can link multiple tanks together. The bottom right picture, you can't really see it, but we had 3 15,000 gallon tanks linked together for a single 45,000 gallon system. That was in the University of Miami. Generally, these tanks, you take a pretty heavy leap forward in cost when you go to a fiberglass tank. They're made to order, so these tanks are not sitting on a yard somewhere waiting for your order. You specify the inlet size, the outlet size, the manway, all that stuff. So generally they're quite a bit more expensive, but they are very durable. These are the same tanks that are under every gas station in the United States. The water tanks are single wall tanks. The petroleum tanks are actually double wall tanks, so they're a little different. But these are very common tanks, very common in commercial applications. Again, you can get a H25 vehicle load rating out of it, so you can get, you put the heaviest fire truck out there on tops of these tanks. Again, very durable, tried and true technology. Corrugated steel tanks. These are they're basically like the grain silos that you would see all over the place. The water inside doesn't actually come in contact with the steel. There's a liner, a PVC liner that goes inside there, so the steel just acts as the structure that holds the liner in place. These are the tanks that Home Depot has implemented. We've done, I think, 45 in Florida. They've done their first 5 stores up here in Atlanta recently with these style tanks. They're actually pretty affordable. You can get them a variety of different sizes and diameters. So see it pretty often in commercial and residential applications. You see these tanks a lot with private owners like, Home Depot or, someone, or Starbucks has done quite a few of these, where they're trying to display the fact that they're doing rainwater harvesting. They're probably doing lead projects. They want to be able to brand the tank like Home Depot's done here, and show you that they're doing rainwater harvesting and make a kind of a marketing piece out of it. Modular tanks. This is actually a stormwater product, kind of retrofitted for rainwater. This was an 80,000 gallon system we did at Dan Farrell High School in South Atlanta for irrigation and toilet flushing. Basically, the way these systems work is you're dealing with these individual units or modules. It's just originally this was a stormwater product where you would wrap these things in geotextile fabric, take your inlet pipes into them, it would store the water, and it would just then percolate back out slowly over time. What has happened is basically that the industry has taken this product, and rather than wrapping it in the geotextile fabrics, now we'll wrap it in PVC liner, so it actually becomes a tank. The unit itself is actually just creating a structural void below grade that'll hold the water, and then you wrap it in the liner to create the tank wall. These are great because you can make them any size. One single module I think is 32 gallons, and then you can stack them 5 high and configure them in just about any array you need to come up with larger capacities. So there's another one, the old 4th Ward Beltline Park over there has one of these systems in it, about a 20,000 gallon system in it. So they're good. You can take a if you have a very defined space that you want to put your tank in, you can maximize your storage by designing around the space of this unit. Theoretically, you could, the storage volume with these is infinite. You could build as big a system as you could wrap a line around. They'll also handle H25 vehicle loads. This was under the bus lane at Farrell High School, so they had their school buses riding on top of this thing. And the interesting thing about this one is this was the rainwater tank, and then it actually overflowed into a very similar system that managed the stormwater. So they collected as much as they could on the front end, and when it overflowed into a detention system. So they handle all their stormwater on site, use what's possible, and then the rest overflows. Okay, pump systems. Generally, probably most common we'll see with rainwater harvesting submersible pumps. We'll talk about why. We'll talk about these are what I would call site-built pump systems. Usually you see this with smaller systems where the plumber or the irrigator is going to take a pump out, and they're going to plumb it up themselves and make all the connections, do all the check valves and everything, install everything themselves, so they'll plumb it all on site. Basically, we would size the pump to the project needs. If you had an irrigation system that required 30 gallons a minute at 50 psi, we would choose the right pump for that. Or if you're using toilet flushing, we would kind of analyze what your instantaneous demand was and choose a pump based on that. A lot of times with these type of systems, you don't get as much as control as you do with some of the package systems we'll talk about in a minute. You may have a separate level controller telling you how much water is in the tank, that sort of thing. But these are generally smaller, kind of site-built systems. And again, usually you're seeing these systems up to 100 gallons a minute or so. Then you would move over to a package pump station. These are usually larger commercial applications that have higher volume and pressure needs or more control needs. For instance, with these, you can tie these systems in. This is a package pump station. That's the control panel there. You can tie that into a building monitoring system and get real-time feedback about how much water is in your tank, whether the pumps are running, what type of alarms you have, which especially becomes important for lead-type operations where you have to quantify how much water you're saving over your baseline, that sort of thing. So with these systems, again, they're generally more expensive systems because you have so much more capability with the controls. They have alarm logs. If you have an alarm, a low-level alarm, high-level alarm, burst pipe, whatever, you can go into the system and see, most of them go back 2 years and see what type of alarms you've had, so they help you troubleshoot the system. They're factory tested before they leave the site, so it's built in a controlled environment and tested to its full capability before it goes to the site. So theoretically, it should be an easier installation because you get there, you plumb up the skid, and get it running. So. Water treatment. So a lot of these systems that we've done have been used for toilet flushing, and some of them even potable systems. Per code here in Atlanta, if you're going to bring the water back in the house, it needs to be disinfected. The most common way we see that being done is with sediment filtration and UV sterilization. A UV sterilizer basically exposes the water to a dose of UV light that renders anything, viruses, bacteria, things like that in the water, renders them so that they can't reproduce. It actually doesn't kill anything, it sterilizes it in that fashion. For you to utilize a UV sterilizer, you have to filter down to 5 microns first. So typically you'll see a filter bank like this with maybe a 20 micron, a 5 micron, and maybe a 1 micron carbon filter, followed by a UV light. We've done potable systems, many potable systems with using just that technology, and gotten really high water quality. In most cases, higher than the municipal water available at the source. So that's probably the most common, because really all you have to do is, you have to change your filter elements periodically, change the UV bulb once a year. So that's probably the most common. That's becoming the industry standard for disinfection. The other common thing we see would be like chemical injection, chlorine injection. This little board would do something like that. Basically where you're actually injecting chlorine into the water system. We don't see quite as many of those. It requires a lot more ownership. Under-chlorinated water can be just as dangerous as over-chlorinated water. So you have to dial in just the right amount, make sure you're getting just the right amount of chlorine in your system. And you have to handle a dangerous chemical, things like that. So don't see them implemented quite as much, but fairly regularly. The difference is chlorine does leave a residual. So if you chlorinate water, if you add chlorine to it, it's going to stay chlorinated. If you're treating with UV and sediment filtration, that needs to be kind of at the source filtration. You need to pump your water through it, pump it through the UV and the sediment filter, and then hopefully use it immediately, because UV sterilization doesn't provide any sort of residual. If you just put that water in a tank after it's been through a UV sterilizer and left it there for a while, there is a possibility it could go back the other direction and go bad, if you want to call it that. But despite that, UV and sediment is probably the most common, followed by chlorine. Auxiliary water supply. So almost all these systems we do have some sort of backup water supply in the event that you have a drought, or if your pump goes down, or any myriad of reasons you want to switch to the backup water supply. Usually those sources are either municipal water or well water. There's a few different ways to implement a backup system. What we call tank backup is when you add the water directly to the tank. Very easy, affordable way to do it. But if you're just using rainwater and you're adding all your clean backup water to the tank, and your pump goes down, or you have to take the system down for maintenance, you kind of got all your eggs in one basket. All the water's in the tank, and you got no way to get it out. We still need to see it done in some applications. Usually not if it's a primary function like toilet flushing. Usually you're going to do direct backup. And direct backup would be when the water level in the tank gets low, you switch directly to a backup, either municipal or well source. That's commonly done with three-way valves. So here you have a 3-port valve. You would have the rainwater coming in one side, and say your municipal water coming in the other side. And you would have a level control in the tank, and usually you're setting a user-defined limit. You'd set a low-level set point, and if you're running on rainwater, and then you hit your low-level set point established by your flow switch or a little digital controller. You hit your low-level set point, the valve switches and automatically switches to the backup water supply. So almost all the systems we see have some sort of backup water supply system on. When you're doing direct backup, backflow prevention becomes very important. You don't want to cross-contaminate any other water source. So typically on the municipal or well supply side, you'd have a backflow preventer so that you don't feed your rainwater back into the municipal system. Although sometimes it might not hurt to have a little rainwater in there. But and so this can be done in quite a few ways. Again, old school way, most tried and true is float switches. Set some low-level, high-level float switches. We just flip-flop back and forth between rainwater and city water. There's a myriad of digital controllers that have a digital probe that hangs down in the tank, and you can go in the unit and program your low level and high level set points. And again, it's just going to be a valve or something to switch back and forth with between rainwater and city water. System maintenance. So all these systems, just like any mechanical system in any building, require some maintenance. Usually you're going to have, as I mentioned, some maintenance with the pre-filter, even though they call them self-cleaning. You're probably at a minimum of 4 times a year, no matter what type of system you have. You're going to have to pull that stainless steel filter element out, clean it off, make sure the biofilm isn't forming on there. Again, occasionally you'll have tank cleaning, although you'd be surprised how infrequently it is. You know, a lot of these systems that have been installed in Atlanta have been in for 5, 6, 7 years, and probably the tanks have never really been cleaned out. All that's really forming down in there is that sediment bed on the bottom, and again, it's not that detrimental to the system as long as you're treating it right. But occasionally you would have to probably clean your tank out. Pump maintenance, pumps by their nature fail, so you're either going to have to maintain a pump or replace a pump at some point. Depending on what kind of pumps you're using, that may be changing mechanical seals in the pump, changing out some of the electronics in the pump. But at some point you will have some maintenance to do on your pump system. And then water treatment. The water treatment components we talked about, the filters. If you're using the canister filters, you'll have to change those out when they get dirty. The UV bulbs, you would have to change the UV bulbs out once a year. Most UV bulbs are designed to last about 10,000 hours, which is roughly 1 year of continual use. If you're doing a chlorine system, you'd have to add chlorine and monitor that chlorine. And that's basically what we're talking about with the system maintenance. I believe that's all I got. Yep, that's all I have.